All right, this is the notes for the Unit 5, which is about graphing. And we're going to start with just some basics of graphing, which is just how to graph a point, just in case you don't know, this might be review. And then we'll talk about X and Y intercepts in a picture or a graph. And then we'll talk about distance, midpoint, and then circles. So let's just start with what a coordinate plane is. Some of you have seen it, some of you haven't. So a coordinate plane is two perpendicular number lines that intersect at 0. And the coordinate is the location of a point on this plane. So we're going to refer to this graph paper as a plane. And we've got two axes. We've got our y-axis, which is up or down. And then we've got our x-axis, which is left or right. Now in our axes, if we're thinking about a number line, the origin is where they're both 0. So if I go to the left, those are negative numbers. And if I go to the right, those are positive numbers, just like a regular number line. But now we're going to do a number line which is up and down. So our up and down number line is called our y-axis. And so again, in the center is at 0. So we're going up, up, up will be positive. And down, down, down will be negative. And you can see that we've kind of broken our graph paper into 4 quadrants, 4 sections. So we call those quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So there's 4 quadrants. And the origin is basically the center. So every coordinate is going to have both an x part and a y part. So the x part is always first, and then we use a comma, and then the y part is second. Now this kind of looks like an interval, but the context tells you that it's a location. So if I wanted to draw something like the location 2, 3, the 2 is the x part. So this is either going to be left or right. Oops. Left or right. Now, how do you know? You know whether it's either left or it's right based on whether it's positive or negative. So since 2 is positive, we're going to go to the right. So we're going to start at the origin and move right 2. But then similarly, we've got the 3 here. The 3 is the y part, so that's either going to be up or down. And again, how do you know if it's up or down? Well, it's based on the polarity, or whether the number is plus or minus. So since 3 is positive, we'll go up. So now we're going to draw this coordinate. Let me get the same color. We're going to start at the origin. Remember, the origin is where both of your x-axis and your y-axis, where they intersect, and it's their zeros. So the origin is 0, 0. 0 on the x, 0 on the y. And so now we're going to start at 0, 0, and we're going to count right 2, 1, 2, and we're going to count up 3, 1, 2, 3, and this is where our point lands. So this point is the location 2, 3. So now we can kind of build on that and talk about intercepts. So the x-intercept is the location where your picture touches the x-axis, meaning the y part of the coordinate is 0. And the y-intercept is the location where your picture touches the y-axis, meaning the x part is 0. And when you have a picture, finding the x and y intercepts is not so bad. For example, in this first one, if we want to find the x-intercepts, that's where our graph touches the x-axis. So this is our x-axis here. It's the left and right. And you can see our blue picture touches at these two locations. So the x-intercepts. So let's do the point on the left first. This point here, if I want to get to it and I've started from the origin, I have to go left 3 and up 0 because I'm not coming off of the x-axis. So that location would be -3, 0. And then similarly, this point on the right, to get to that point from the origin, I count 3 to the right and I go up 0 because again, I'm not coming off of the x-axis. So that location is +3, 0. So my x-intercepts are going to be these locations -3, 0 and 3, 0. If we want to do our y-intercepts, it's the same idea, but now we're looking for where it crosses the y-axis. So we can see it crosses the y-axis here and here. So let's find the coordinates for that. So again, think about starting right at this origin. If I want to get to that top point, I'm going to go up 1. So let me write that down. Oops, intercepts. We're going to go up 1. But we're not moving left or right anything. So we're going right 0. Now remember, you always put the left or right first. Always put left or right first, and then you always put up or down second. So for this point, we have 0 left or right, and then up 1. So this point will be 0, 1. So now let's look at the lower point, this point down here. To get to that point, all I'm doing is going down 9, but I'm not going left or right, right? I'm going 0 to the right or 0 to the left, however you want to think about it. So this coordinate will be 0, -9, because remember, down was negative. So the y-intercepts for this graph is going to be 0, 1, and 0, -9. So a graph is just a picture, and that picture has coordinates. Now you can tell there's a lot more coordinates on this picture than just the 4 that I marked, right? And we'll talk about that in just a second. So now sometimes you don't have the picture. Sometimes you don't have the picture. How can you find the x and y intercepts? Well, remember, the x-intercept is where your graph touches the x-axis. And when you're touching the x-axis, the y part of your coordinate is 0. So you see here, this is an equation, and it's got both an x and a y. So for finding the x-intercept, we're going to let y equal 0 and solve for x. So I'm replacing y here. Here's my y. I'm going to replace that with 0. So I have 0 equals absolute value of x minus 6 minus 2. Okay, well, we're at solve for x, so you have to think about what kind of equation is this? This is absolute value equation. And to solve an absolute value equation, we need bars equals number, And then we can drop the bars and tack on plus or minus. So I need to get the bars alone. So I'm going to plus 2 over to the other side. So I have 2 equals bars at x minus 6. So remember to drop the bars here because you don't want bars. You have to tack on plus minus to the number. So that gives me 2 equations. I've got x minus 6 equals positive 2, and x minus 6 equals negative 2. So what I'm going to do to solve both of those is add, add 6. So that gives me x equals 8 and x equals 4. Negative 2 plus 6 is 4. So what does that mean? That means that the x-intercepts for this graph are going to be at 8, 0 and 4, 0. So now let's try for the y-intercepts. So the y-intercepts is where the graph touches the y-axis. So I'm going to come over here so I'm not kind of... Whoops. Okay, so the y-intercepts is where the graph touches the y-axis. And that means that it didn't move left or right. So the x part is equal to 0. So in my equation, I'm going to replace all my x's with 0, and I'm going to find the y that goes with that. So I've got y equals absolute value of 0 minus 6, and then minus 2. But I could do 0 minus 6. That's negative 6. So y equals the absolute value of negative 6 minus 2. Now this is not an absolute value equation to solve because the variable is not inside the bars. Inside the bars is just a number. So we're going to evaluate absolute value of that number and then continue on with our process. So absolute value of negative 6 is 6. So I have 6 minus 2. So y equals 4. What does that mean? That means the y-intercept, if I drew the graph, it would touch the y-axis at 4. Remember, y is always your second part. The first part of that coordinate was 0, meaning we didn't move left or right. Okay, let's try another one. So find the x and y intercepts for this equation. So if I was going to draw the picture, where would the picture touch the x-axis and where would the picture touch the y-axis? So for the x-intercept, we're going to let y equal 0. So in this equation, I'm going to replace all of my y's with 0. So I have x equals negative 0 squared plus 36. So now 0 squared is 0, so I have negative 0 plus 36. But negative 0 plus 36 is just 36. So what does that mean? That means the x-intercept is 36, and the location 36, 0 is on the graph. Okay, let's do the y-intercept. So for the y-intercept, the graph touches the x-axis, or sorry, the y-axis, so the x part is 0. So for the y-intercept, we want x to equal 0. So in my equation, I'm going to replace all my x's with 0, and I've got 0 equals negative y squared plus 36. So now the thing I'm solving for has a squared on it. So this is quadratic. Oh no, I did it in blue. Let me go back and change it to purple. So 0 equals negative y squared plus 36. Okay, so this is a quadratic equation because the thing that I'm looking for, my variable, has a square on it. So we have several ways that we can solve that. In this case, since there's only a y squared and not a y single, I'm going to get y squared by itself, and then I'm going to square root both sides. So to get y by itself, I'm going to just plus it to the other side. So I have y squared equals 36. And then I need to kill the square, and we kill squares with square roots. But when you do that, you have to tack on plus or minus. So my equation becomes y equals plus or minus the square root of 36. But I could do the square root of 36, that's 6. So y equals plus or minus 6. So that means the y-intercepts are 6 and negative 6. So the location 0, 6 is a y-intercept, and the location 0, negative 6 is a y-intercept. Now let's move on to distance and midpoint. So for distance and midpoint, if you've got 2 points on the graph, right, you can find the distance between them, and you can find the midpoint, the location, which is halfway between or equidistant between the 2 points. So let's focus on distance. The distance between 2 points, which we'll call one of the points x1, y1, and the other point x2, y2, their distance is going to be the square root of x2 minus x1 squared, so the subtraction of the x's squared, plus the y2 minus y1 squared, which is the subtraction of the y's squared. And that is under a square root. So let's try using this distance formula. It's really just a plug and chug equation. So I'm going to call my x1 negative 2 and my y1 negative 3. So we'll call this guy x1, we'll call this one y1. And then remember, those are going to go as x1 and y1 here. And then our x2 will be 4, and our y2 will be 4. So these guys will go x2, y2. So I want you to see how you group the x's together, you group the y's together, excuse me, and subtract them, square them, add those, and square root. Let's try it. It sounds like a lot of steps, but it's really pretty straightforward. So the distance between these two guys is going to be the square root of x2, so 4, minus x1, -2, squared, plus, and then y2, -1, minus y1, which is -3, that whole thing squared. So now I need to do 4 minus -2. So 4 minus -2 becomes 4 plus 2, which is 6. And 6 squared is 36. And then similarly, if I do -1 minus -3, that becomes -1 plus 3, which is 2, and then I square that, which makes 4. So the distance between these 2 points is the square root of 36 plus 4. Now you can't take the square root of 36 and take the square root of 4 and add them. You have to add them first because adding is under the radical. So this makes the square root of 40. Okay, that's the distance between them. Now remember, you have to simplify your radicals. So let's see, 40 is 4 times 10, and 4 is 2 times 2, and 10 is 2 times 5. So we've got a double 2, so 2 goes outside, and then 2 times 5 goes inside, so 2 square roots of 10. So the distance between these 2 points is 2 times the square root of 10. So you always want to simplify your square roots if you can. Now midpoint is a location. So midpoint is a location, which means it's going to be a coordinate. So if you want to find the distance between 2 points, again, we're going to label them x1, y1 and x2, y2. Then the midpoint between them is x2 plus x1 over 2, y2 plus y1 over 2. So we're basically taking the average of the x's and the average of the y's. So again, we've got these same 2 points, -2, -3, and 4, -1. We're going to call these guys x1 and y1. We'll call these guys x2 and y2. So now to find the midpoint, I'm going to take x1 and I'm going to add it to x2, and I'm going to divide that by 2. And then the other part of the coordinate is we're adding y2 and y1. Remember, adding is commutative, so it doesn't really matter which one you call y2 and which one you call y1, as long as they're the y parts. So I'll do -3 plus -1 over 2. So now here, -2 plus 4 is 2. So I've got 2 over 2, which is 1. And then over for the y part, I've got -3 plus -1, which makes -4. So I have -4 over 2, which is -2. So what does that mean? That means that the location right in between these two is 1, -2. So remember, this is the location. This is halfway between the 2 points. So you do have to memorize these formulas. So memorize those formulas so you can find the distance and the midpoint between 2 points. Now, the distance and midpoint we're going to use in this next section. So let's talk about circles. So circles is kind of our last topic for Unit 5. Circles, think about what a circle is. A circle is a set of points which are the same distance away from a center point, and we call that distance the radius. So all the points are going to be listed as x comma y, but to designate that we've got a center point, we're going to call that center HK. So now, if you want to list all of the pairs XY that are on the circle at a certain radius from a certain center, we use, it's very similar to the distance formula. We're going to use this formula here. X minus h squared plus y minus k squared equals r squared. And this is just the distance formula. With xy and hk. So it's really just the distance formula, but instead of calling distance d, I'm calling it r because it's a radius. Instead of taking the square root, I just moved the square root over to the other side as a squared. So that's where that comes from. So now, let's take this equation, x squared plus y squared equals 25, and write it in this standard form. So instead of writing x squared, I'm going to think about it as x minus 0 squared. And then similarly, instead of writing y squared, I'm going to write it as y minus 0 squared. And that's equal to 25. So now, what I did was I lined this up with the formula for a circle, which again, you do have to memorize. Excuse me. So, we can tell that, let me get a different color here. Let's do blue. So minus 0 is the same as minus h. So if I wanted to find h, I could divide both sides by -1, and I get h equals 0. And then very, very similarly, I've got y minus 0 lined up with my y minus k. So I can say that that minus 0 equals minus k. And to figure out k, I'll just divide everything by -1, and I get 0 equals k. And then the last thing that I'm going to line up is 25 with r squared. So I'm going to say that r squared, or that 25, is equal to r squared. Now, we can square root both sides to kill that square. So we get r equals plus or minus the square root of 25, which is plus or minus 5. Now, you're probably thinking, hey, a circle only has one radius, and that's true. When we're talking about radius, the radius is always positive. So my r would be 5. So to describe this circle, I would say the center is at 0, 0, and the radius is 5. Okay, let's try another one. We're going to line it up again with the standard form of the equation. So remember, the standard form of the circle is x minus h squared plus y minus k squared, and that's equal to r squared. So let's make our 3 equations. I know that minus 2 has to be the same as minus h, which if I divide both sides by -1, I get h equals positive 2. And then over here, positive 3 has to be the same as minus k. So minus k equals positive 3. And to get k alone, I'm going to divide by -1. So k is equal to positive 3 over -1 is -3. And then lastly, we're going to equate, excuse me, oh no, I lost my whole thing. I'm going to equate positive 12 and r squared.
I'll try to close the door for you.
Thank you. So r squared has to equal 12. So r has to be the square root of 12. And remember, it's always positive since it's referred to as a radius. So it's the positive square root of 12, which we should simplify. So 12 is 2 and 6, and 6 is 2 and 3. So that radius is 2 square roots of 3. So now let's answer the question. Now that we did all the math, the center is h comma k. So that would be 2 comma -3. And the radius would be 2 times the square root of 3. Just a coincidence that there's 2's and 3's in both. Okay, so now, what if your circle is not in standard form? So check this circle out. I know it's going to graph a circle because there's both an x squared and a y squared. And that's really the only thing you know how to graph right now is a circle. Or the only equation you know that is a standard equation for some picture. So if we want to write this in standard form, our goal has to be x minus h squared plus y minus k squared equals r squared. So for this guy, what we're going to do is we're going to use completing the square. Remember, everything comes back in this class. So for completing the square, we had this rule. I'm just going to write it like real quick. So we had to force the coefficient of x squared to be 1, and then divide the x coefficient by 2, square it, and add it to both sides. Okay, so I'm just going to organize my equation real quick. I'm going to put my x stuff together. So I have x squared minus 4x. I'm going to leave a little bit of space. And then I have plus y squared plus 2y. And now I want to move this guy over to the other side by plussing it, because I don't want any other numbers on this side. I'm going to put the numbers on the left. So, and then I'm going to also put them on the right. I don't want that 20 hanging out on the left. So now let's talk about completing the square. My x squared has a coefficient of 1. So I'm going to take the number with x, which is negative 4, divide it by 2, which is negative 2, and then square it, which makes positive 4. So to complete the square, I need to add 4. I'm going to do that on both sides. So now, remember the trick when you factor this, it's going to come out to a perfect square. This one is x minus 2 squared. Well, let's do that again, but let's do it on the other side. So, or not the other side, but for the other variable. So let's look. We've got a y squared, and it's got a coefficient of 1, right? There's no number with it. So I'm going to take the number with y, positive 2, and I'm going to divide it by 2. That gives me positive 1. And then I'm going to square that, which gives me positive 1. So I'm going to plus 1, but it's an equation, so I have to plus 1 on both sides. Now this guy here can also be written as a perfect square. It factors into y plus 1 squared. And now we've got our equals. Over here, 20 plus 4 plus 1 equals 25. So I wrote the equation in standard form here. I really don't want those lines on there though, so I'm going to erase those lines. Okay, now on top of that, we need to use this to find the center and the radius. So remember, we're going to line it up with the formula. And I'm going to make 3 equations. So here, negative h has to equal negative 2. So to get h alone, I'm dividing by negative 1. So h equals positive 2. And here, I'm going to equate these guys. So I'm going to say negative k equals positive 1. So to k alone, I have to divide by negative 1. So k equals positive 1 over negative 1 is negative 1. And then the last equation is r squared equals 25. So if we square root both sides, we get r equals 5. So now what did that tell us? That told us that our center is 2, negative 1, and our radius is 5. Now, to graph this, in Alex, all you're going to do is you're going to use the circle button in Alex. So you'll be on the graph, you'll hit the circle button to graph, and then the first thing it's going to ask for is the center. So you're going to click on the center. Then you're going to count the radius in one direction. And click. And Alex gives you like a beautiful, beautiful, beautiful graph. But since we're doing it by hand, we're going to count the radius north, south, east, and west from the center. So my center was at 2, 1. So that, or sorry, 2, -1. So that's 2 on the x and -1 on the right. So there's my center. And now I have to count out north, south, east, and west, 5. So starting at the center, that red center, I'm going 1, 2, 3, 4, 5 north, 1, 2, 3, 4, 5 west, 1, 2, 3, 4, 5 south, 1, 2, 3, 4, 5 east, and then I'm just going to do my best to connect those with a circle. So now to go the other way, let me go back here. In these problems that we just did, we had an equation and we used the equation to get information. So let me write that down for you. In these ones, we used equation, EQN, equation, to get information. Now, oh no, sorry about that. Okay, so now in this next part, we're going to have info and we're going to get or make the equation. So that's why I'm saying we're going in the opposite direction. So let's start here. We want to write the equation for a circle that has a center of 3 and a diameter of 4. So we know that the equation for a circle is x minus h squared plus y minus k squared, and that equals r squared. So in my formula here, my h is 7 and my k is 3. So I can replace h with 7 and k with 3. That's going to give me x minus 7 squared plus y minus 3 squared. Now for r, they didn't give us r, they gave us diameter. So the diameter of a circle is the distance straight across through the center. So if this whole thing is 4, then each side is 2. So my radius is equal to 2. So here I'm going to replace my r with 2. So I have 2 squared. So to write my final equation here, I'd write x minus 7 squared plus y minus 3 squared equals, and then 2 squared is 4. Now this 4 is not related to the diameter of 4. It's just a coincidence. And this is my equation in standard form. Let's try it again. So in this one, we're going to write the equation for a circle where -2, -3, and 4, -1 are the end points of the diameter. Whoa, what does that mean? Because remember, for a circle, you need x minus h squared plus y minus k squared equals r squared. But they did not give us an HK. They did not give us an R. They gave us 2 points, which are on the circle. So that means that if I have this circle, which is really good drawing, one of the points over here on the circle is -2, -3, and one point directly across is 4, -1. So that's what a diameter means. And remember, a diameter goes through the center. So for this guy, I think we could find that center because the center is the midpoint of the diameter. Now, I know you probably don't remember, but we actually did the midpoint of these 2 points a couple pages ago, right? The midpoint was 1, -2, so this is page 2, so I'm just going to write that. Oops, one more. So from page 2, the midpoint was going to be 1, -2. So that tells me my H is 1 and my K is -2. So when I put those in, I get x minus 1 squared plus y minus -2 squared. And now for R, well, this is a diameter, so the radius is half of the diameter. Now, we did the diameter on page 2. Let me go back up and get the number. So the radius was square root of 40 or 2 rad 10. Now, I want to show you here, because most of the time you haven't already done this. So the diameter was the square root of 40, which is the same as 2 square roots of 10. Now, when I divide by 2, because that's what half is dividing by 2. In this guy here, you cannot, so you can't put the 40 and 2 together, which is a really common mistake. A lot of people want to call this the square root of 20, which is not true. You can't put the 40 with the 2 because the 40 is under a radical and the 2 is not under a radical. So if we look on this other side, so get a different marker here. If we look on this part, we can put the 2's together because neither one of them are under a radical and they actually cancel out. So our radius is the square root of 10. So I'm going to replace R with the square root of 10. So my equation has equals R, square root of 10, squared. Now this equation needs a little cleaning up, okay? X minus 1 squared is fine. But now y minus -2, that's y plus 2. So y plus 2 squared. And now what's the square root of 10 squared? Well, that just makes 10. So the equation for this circle is x minus 1 squared plus y plus 2 squared equals 10. And that took the information that they gave us, and we made an equation out of it. All right.